Linux In-Laws, a podcast on free Libra open source software. Broadcasting from the United Kingdom and Germany.
Welcome to Linux In-Laws, Season 2, Episode 60. Martin, how are things tonight on this wonderful kerfuffle, chuckle evening, that is? Of course, that's the season I just invented.
Okay, good. Yeah, well, seasons are
changing anyway, aren't they?
No longer that relevant, to be fair.
Exactly. So, Greta, if you're listening, if you want to send us season names, please be our guest. And while we're on the subject of strange things, we should probably tell what this episode is all about.
Well, I think you've had a few beers, and then you had an idea to talk about some more obscure programming languages.
That was back when we got together in person, right?
Isn't that every day? Oh, sorry.
No. No.
Okay. It's fine every day. Right, fair enough.
No, despite what your maths say, this is not the case. No, okay. Martin and myself basically had this wonderful idea when we kind of met in person in 2020. Oh, I can't actually reveal the year because that was exactly
sometime in the past.
Sometime in the past, because that would kind of violate data protections issue, what have you. Anyway, when we last met, let's see with that basically, we had this wonderful idea of discussing strange and wonderful and really esoteric programming languages. Now, before we go into the details, we should probably explain to the non-technical listeners in the audience what a programming language is.
Okay.
So, Martin, what is a programming language?
What's a programming language? A programming language is, well, a language to write programs in.
Perfect.
Unlike a language to write in.
Thank you for listening.
Write books. Indeed. Yes, so if you want to tell your computer what to do, you need a programming language.
So when did programming languages surface, I wonder?
Well, I guess that depends on what you define a programming language. But any calculation machine needs a set of instructions, right?
Exactly. Going back to the basics now, what is a computer, Martin?
Depends. They come in many shapes and sizes and forms, but in short, most of them have a number of components. One of them being the main one being obviously the CPU or central processing unit, which can carry out instructions.
Okay.
And then there's bits like memory and stuff to remember things and interfaces to deal with peripherals, etc. Yeah.
Is it fair to characterize a living being as a computer?
Well, things are processed, so yeah, from that point of view. It's
so
just an analog thing, right?
So the first
no transistors involved.
Exactly. So the first computers evolved when? When did living beings came into existence into the ocean? What 60? No, it must have been more.
Well, it depends if you count bacteria, right?
Exactly. So programming language have been around for the last at least couple of billion years, if memory serves correct. I said to be corrected, but fast forward to electronic gadgets.
Good. Yes. Of course, there was also the mechanical era of computing, but we'll skip that one.
Mechanical
of time.
Okay. Yes. I mean, we only have 4 hours, so let's focus on the relevant stuff. Okay, computers were invented, I think, in.
It depends what you call a computer, right?
Electric ones. Sorry, electronic. Electric, not electronic, but electric ones. Like 30s, 40s, right? 30s, 40s.
I think it was before then, to be honest. Yeah, I mean,
really?
There were obviously things like valves involved and all sorts of stuff before transistors and things like that.
SUSE did a set 3 on relays, based on relays rather.
Right. Well, there's obviously the Babbage one, which is the mechanical one.
But that doesn't count as electronic or electric, does it?
No. Anyway, yeah, you're probably right. Somewhere around the 40s, isn't it?
So even if we fast forward more, it's probably fair to say that real programming languages came into existence when computers were based on transistors. Yes, no, maybe.
What's a real programming language?
As in
something to do with fishing, or
exactly.
Okay.
So you cast a net and then hope for the best.
Sounds good. Yeah.
No, fast forward kind of to the 40s, 50s. Shockley had this idea of doing this transistor thing. And then people came up with CPUs and all the rest of it. Details in history books, or maybe even in the show notes, you never know. But it's probably fair to say that real programming language emerged in the 50s, 60s, and 70s of the last century.
That's fair. Yeah. Yep.
When people had this idea of
Algol and Pascal.
Exactly. When people had this idea of, yes, we have some sort of operating system, but we do not want to program the CPU in bytecode anymore.
Indeed.
But we want to use some level of abstraction on top of this assembly language.
Mm-hmm.
Hence the notion of compilers, interpreters, and all the rest of it.
Yeah.
And hence programming languages were born. For example, COBOL for the business stuff back in the 50s, 60s.
Ada, yes.
Fortran around the same time for more scientific problems. Ada actually came later when the Department of Defense,
I remember Ada,
DoD, exactly, had just way too much money to spend, and standardization committees were all the rage. So they invented a language like, I think Simula was similar for Ada, and some other languages. And these kind of, this is pretty much the history, but let's kind of focus on things outside the beaten track, so to speak, or the beaten path. Like
Rust, I see.
I wouldn't call it an esoteric language, because if you invoke Firefox, most of it is written in Rust. So that's not an esoteric language.
Well, it depends. Anyway. Depends on your definition of esoteric, but maybe we should explain this to the listeners.
What is an esoteric programming language?
Indeed.
I would hazard a guess. An esoteric programming language is not used by more than 1,000 people on the planet.
That sounds like Rust.
And
never mind.
No, Mark. Mark, you haven't looked at GitHub recently, have you?
I look at it pretty much every day, to be fair. Anyway.
Do you know? Maybe you look in the wrong corners. You never know.
It's
another
more,
trait of esoteric languages is probably, and
not
I'm
widely used,
guessing here,
and
not widely used, and also probably not more for fun, and probably not just in kind of still waiting for the commercial breakthrough.
Well, not necessarily waiting for it. That was probably never an intention with some of these things, to be fair.
Exactly. I mean, some esoteric programming languages have gotten very, very close, but you see, okay, should we kind of venture into the abyss?
We can do. Yes.
We can.
Yes.
Maybe we should start with a more popular esoteric programming language called... Popular, yes, as in it was all the rage back in the 70s and 80s.
Well, I don't know if it fits the description, of esoteric language, but
So would you call Prolog, as in the theorem solver, an esoteric language or not?
Personally, I wouldn't know. It's since I had to learn it at university.
You had to learn it, so it's not esoteric. I see. Okay.
Yeah.
No, as a matter of fact, I mean, there's no hard and cut definition of an esoteric language. We're just making things up as we go along, of course. But the idea is basically to extend the notion of the typical programming language realm beyond the usual suspects like Rust, C, C++, Golang, maybe even TypeScript, JavaScript, you name it, to shed more light on what else is out there, not necessarily kind of from a pure deployment perspective, because some of the stuff we're going to discuss is pretty esoteric in terms of it's hardly used at all. in terms of production deployment and stuff. But some of this stuff is actually quite funny. But we're going to get into this in a minute when we discuss programming language like Brainfuck, Bullshit, Ook, and some other candidates.
I like Arnold C personally.
Okay. So the idea is actually to venture from the more known languages like Prolog into the dark corners of the abyss, so to speak.
Okay.
So what do we know about Prolog, Martin?
Well, quite a bit. But,
You learned it at uni? That was about,
yes.
60 years ago? Yes. Okay, fair enough. And what happened after?
Yeah, I may have forgotten quite a bit.
Yes, okay.
Yeah, it's nothing like your, let's say, your Pascals, your Pythons, your the standard constructs like if and while loops and all that kind of stuff. Right? It's very different, differently organized and very wordy in a way. It's more like a not sure how to describe it, but it's everything is written with a bunch of words, and I don't know what the intention was at the time. It seemed all very theoretical. I couldn't tell you if it was used anywhere, but it makes for a good, let's say, education language. That's for sure.
Oh, it does. I mean, the idea was basically to implement a theorem solver. And in terms of, you have a theorem that depends on other theorems.
Yes.
And then basically you solve this.
Yep.
So it was very logic bound. And the idea was basically to directly translate mathematical formulas, theorems, what have you, into a programming language, which you could then use to say whether the theorem is correct or not.
Yeah, I don't think it ever got that far, to be fair, but I could be wrong. Certainly not.
I mean, the commercial adoption was quite limited. For example, there was a programming language called there was a database system rather called TerminusDB, or there still is, because we had them in the show a couple of years back. And one of the components was actually Prolog, because one of the CLI parts was implemented in Prolog.
Yeah, that kind of makes sense. It's kind of you can ask questions and stuff and all that kind of things. Part of your theorem solving, I guess you could use that for querying as well.
Yeah, and that was probably the last major commercial adoption of that technology. I'm almost tempted to say in the last 10, 20 years or something like that. Not sure if it's still used in TerminusDB. We must have them back on to get an update at some stage.
Yeah, indeed.
But that's what I can remember about Prolog.
Yeah, it's been a while. I haven't seen it since.
Okay.
Anyway.
Okay.
But of course, we had, talking about languages we are familiar with, we had Zig on the show as well.
Yes. So what is Zig, Martin?
Zig is, well, did they not call it like a modern C or something like that? It's a general purpose language, right?
It's a transpiler, no?
A transpiler?
Yes, because it takes a variant of C and translates that into C, if I'm not completely mistaken.
That sounds like a two-stage approach.
I mean, what are the disadvantages?
Why not write it straight in C?
You want to ask the project about this? No, I think the idea was basically to have a type safe variant of C, which is then basically checked and translated into C, because as we all know, C goes back to the 60s, 70s, something like that, because Unix was implemented in assembler in C back in the 60s.
Many things
yes.
In C. Yes.
And the language as such has undergone quite a few stages of evolution. But one of the traits it has never dropped was actually loose typing. In terms of, if you want to mingle types, you're more than welcome to. C++, of course, is a different story, but the idea, one of the major ideas behind Zig was actually to provide a type-safe C. In terms of, if you know what you're doing, you can still coerce the compiler, or the transpiler rather, into doing what you want. But out of the box, it does type checking, and I'm almost tempted to say not as rigorous as Rust, but almost kind of like Rust, because as we all know, Rust is heavy on types.
Well, it depends if you use Rust, right? But, yeah.
Well, you can use Rust in an unsafe way, but that defeats the purpose. I mean,
well, yeah. I mean, you've got these unsafe interfaces, right? To
yes,
stuff that.
but
anyway.
one of the main ideas behind Rust is, of course, type safety. That's actually I reckon one of the reasons why many people adopted it for low-level system type programming.
Yeah.
Ranging from Bottle Rocket, we have them on the show too, like this container thing at the bookshop, right up to, well, Firefox probably being the best example, because the parts of Firefox, including the rendering engine, are actually written in Rust these days.
Yeah, you see it a bit more, but hey.
So I wouldn't call Rust an esoteric language.
Well, again, we haven't. Well, according to our definition of what was it, little use and made for fun or anything else.
In that case, Rust probably wouldn't qualify.
True. And well, neither would Prolog and Zig in that case. But yeah, anyway, it's fine. I can.
Are there any major projects written in Zig, I wonder? Probably there are. I don't know.
We must have our friend back on the show as well. Yeah.
The Italian, yes.
Yes.
Back on the show to give an update of what happened.
Yeah. Where is Zig, and why is nobody using it?
I'm sure that there are people using Zig, but I haven't seen it lately. Let's put it this way.
I seem to remember they were pretty well funded, the Zig Foundation or whatever it's called, when we did our episode with them. And
I just hope it wasn't just money laundering.
Well, who knows? Now it all makes sense. Yes.
Does it now? What does it now? Okay.
Well, a certain in-memory key value store makes sense now. When you mention money laundering,
that was a joke. The in-laws do not suspect the Zig project to be.
Oh no, not the Zig project. No, the dodgy in-memory key value store. Yes. Anyway,
that was way back, and people have moved on. I might add, yes. Okay. Anyway, going back to much safer grounds. The next two languages that come to mind is actually a language called Mumps and Forth.
Forth is also vaguely familiar.
Yes, Martin. You never owned a ZX81, did you? Like a Sinclair machine.
No, but friends of mine did, so maybe that's where I know it from then.
And I mean, okay, fast rewind about 40 plus years. It's the early 80s.
Wait. If it's running on a ZX81, then it's by definition not little used because they were very widely sold.
It's not. I'm getting there in a moment.
Oh, okay. Carry on then.
If you choose to hear me out, I mean,
okay.
The people running ZX81s on real hardware, as in the stuff that was sold 40 years ago, probably are a handful on this planet. Many, I reckon, the majority of people using a ZX81 are doing this actually on simulated hardware as an emulator. So, I mean, going back to the early 80s,
you're talking about with the rubbery keyboard, isn't it? Okay.
Exactly.
Yes.
You're looking at the successor of something called ZX80 that was all the rage in
and the ZX
80s,
Spectrum, of course. Yes,
exactly, but that came later. Yes. Okay, the ZX81 had 4K of main memory, a black and white display, and a rubber keyboard.
Which is why I didn't have one. Yes, it was a bit rubbish.
It was not expensive about 46 years ago, and I did happen to own one.
You have that one. Good choice.
Yes, exactly. It came.
You haven't done your research, have you? Anyway, carry on.
It came with a base interpreter at the time.
Yeah,
Another
of course. Everybody has
another
this.
esoteric language, of course. But the alternative was actually to run Forth on it. And that's precisely when I came across that language.
Okay. Fair
About
enough.
40
Fair enough.
years
Well, tell us
ago.
a bit more about Forth, because I don't remember that much of it.
Okay. Forth, it's a stack-based language. It's still in existence, I might add. It had its breakthrough.
Wait. What does that mean, still in existence?
The Open Firmware project uses left, right, and center, for example.
Okay, you mean in use. Okay, yeah.
Still in use now. I mean, sorry, for those few people in the audience who do not know what Open Firmware is, links will be, of course, in the show notes.
Did we not have an episode on this?
No. Martin, we talked about Core Boot.
Yes.
Yes, but Core Boot is not Open Firmware.
No, but it was related. I thought we...
Was it now, Martin?
I think we discussed it in the episode. Anyway, carry on.
Okay, Open Firmware was the grand idea. I mean, we tackled UEFI, and UEFI is probably related.
We talked all about this stuff.
Exactly.
Yeah.
So for these two listeners who listen to us, listen to our episodes one by one. Yes, we had an episode on Core Boot that, of course, also tackled UEFI. As in the Universal Extendable Firmware Interface. But, and this is very important, Open Firmware predates UEFI because Open Firmware was initially just adopted by Sun and some other companies. The idea was to have a portable BIOS-like a software in place that would allow you to boot your machine and then hand over the so initialized hardware to an operating system, like SunOS and all the rest of them. At the time, you're looking at 20 years back or something like that, if not more. And a major portion of the software was actually written in Forth. But again, 20 years back or something like that. That was probably the most recent major adoption of that technology on a broader scale.
Right, because Open Firmware still exists.
It's still in existence, yes, but if you happen to still own a Sun and some other legacy hardware, chances are if you power up that machine, if you dare to do so, you will be greeted by an instance of Open Firmware before you boot into your operating system of choice.
Okay, I don't remember that,
Oh, it goes back some time.
No, I mean, obviously Sun was around for a long time until it was killed off, but...
Well, it wasn't killed off, it was simply acquired in 2008 or something.
Then it was killed off.
Well, the technology still lives on because you can buy servers from Fujitsu that still have Spark in them. And more than one Spark, I might add, because most of them would be multiprocessors. As in a Spark cluster, so to speak, in a single machine.
Yeah, interesting. Okay.
And before we venture into the more esoteric field of esoteric program languages, there's probably an esoteric language we should still mention. It's called MUMS. It's called MUMS.
Yeah, it's
it rings a bell, right?
It's kind of debatable if it's esoteric, right?
It's probably borderline, exactly, because YOTADB is actually written in MUMS.
YOTADB,
yes.
Okay.
The ultra-fast key-value store that, rumor has it, may even beat Valkey or Redis or what have you.
Oh, yeah. Well, I mean, you can write anything that runs faster than anything else, but does it have the same functionality, is the question.
Apparently, it has a built-in key-value store. I mean, that's one of the kind of traits out of the box for that language. Apparently, it's pretty good at multiprocessing in terms of multitasking and multi-threading. Links maybe in the show notes. And that's probably the reason why some people used it for a core banking system, which is not a minor feat in terms of implementation.
Well, yeah. Well, for core banking, you need more reliability than speed.
Yes. ACID comes out of the box with that one.
Okay.
So
just
yeah,
go in that case.
so you have a highly parallel, apparently. You have a highly parallel programming language that implements a key value store that is also ASIC compliant. That goes back, 70 years or something? I'm joking. No, I think it was invented about 30 years ago, something like that. Details wouldn't be shown us, of course. But apart from the core banking thing, that was probably one of the reasons why it was also at some stage heavily adopted in the healthcare sector. Because this is where it came from originally, and it's still used at the present day in software written for that field.
Yeah. Yeah. It's it's a bit of an odd one, isn't it? Writing a specific language just for healthcare. But do we know why they did this?
Yes, because the money came from healthcare originally. Because they
it's a bit like
original
ADA.
project.
Yeah. Okay.
Yes.
Yeah. We have money. Give us a programming language. Fair enough.
Yes.
Yeah.
I mean, ADA came. The money came essentially from the Department of Defense. If I'm not
ADA, yes.
mistaken.
Yeah, I think you're right.
And some other program languages also emerged from similar government efforts in the US. It wasn't similar. It wasn't one of the language, but the name escapes me. That was all the rage about 40 years ago. It wasn't similar. It was something else.
Similar.
That also had this.
Yeah, I remember that one too. Somehow.
That also had this kind of DoD. That was prior to ADA, by the way. That also had this DoD ring to it. As the Department of Defense pouring millions and millions into Senate committees defining a language.
Yeah.
ADA probably being the best example.
They like to pour lots of money in lots of things in defense. Yeah.
I mean, you see, fun fact, Martin, you know the GNU compiler collection, GCC as it is known among friends, the GCC still supports an ADA front end.
Okay.
So you can program in ADA, or ADA as the Americans call it, using GCC. If you choose to do so.
If you choose to do so, yeah, okay.
Yes. Unfortunately, the GCC doesn't support programming languages like Brainfuck or Ook.
Oh, what a shame.
Indeed. So, what is Brainfuck and what is Ook?
Is Brainfuck the one with all the dots and dashes and stuff like that?
Yes. And symbols, exactly. Now for the uninitiated, now we are really entering the field of esoteric programming languages because there is no such thing as a commercial software package implemented in Brainfuck and Ook. Okay, let's rewind a bit. Brainfuck, as the name would imply, it's really an effort to screw your brain because implementing the proverbially hello world alone takes about 20 pages A4 in fine in a small font. No, it's a really weird language. So I mean, you only have about 8 primitives that allow you to implement some sort of logic, and the whole thing rests on cells. As in, you have some sort of variables, but for example, the variable number, because they are all numbered, these cells, advances with the instruction pointer. So if you do not explicitly rewind your variable pointer, once you advance from one instruction to another, so does the variable number, which is really weird. Hence the name.
So, do we know why people decided this was a good idea?
Yes, because people thought that asylums were underpopulated. Hence the name.
Okay.
So, if you want to go down the route of that sweet insanity, this is the program language you want to choose.
Excellent.
Hence the name.
Yeah. Not widely adopted.
Makes sense to me, no?
Yeah.
And Ook, of course, for the uninitiated, is essentially a subset of Brainfuck targeted at young users. I'm not joking. Links, of course, within the show notes. The idea was essentially to model a programming language, how that would be used by an orangutan to simplify programming in terms of it does implement a subset of Brainfuck, and it just uses phonemes that an orangutan would utter, which is really weird when you think about it.
Well, yes, but then that's what the programming languages are about, isn't it? Being weird.
Exactly. So,
well, actually, I think in the case of Brainfuck, it was the guy didn't want to create a complex compiler, so I could get the language as simple.
There are a couple of I think there's at least one interpreter on GitHub that actually does. Yes, that it actually implements Brainfuck.
Widely used, I'm sure.
If you can't get to sleep, or if you think you're not...
If you have tried any other programming language.
Exactly. If you think you're just too sane, that's the GitHub repo you want to look at.
Okay.
On the same notion, I'm almost tempted to say to name bullshit, if that rings a bell.
Well, there is another language that's similar to Brainfuck, right?
No, Martin, it's not Rust.
No, it's not Rust. No, it's called white space, apparently.
Martin, go ahead. What is white space?
White space. You only have 3 characters you can use. Anything else is ignored.
Okay.
So you can use spaces, tabs, line feeds. Apparently, it was an April Fool's joke, but yeah.
Okay. The question begs, of course, is it Turing complete?
Unlikely, yes.
So, what is Turing complete, Martin?
The good news about this language is that every program is by definition secure because you can't read it. It's all blank.
Excellent.
If you look at it.
Going back to my question, Martin, what is Turing complete?
Turing. Well, we have to go back to who Turing was, right?
Who was Turing?
Turing, he was a very important person in the computer history, right?
He was a British mathematician.
What was his first name? Yes.
Alan.
Yes, thank you. I knew it. Yes.
You're welcome. And he really had his breakthrough with deciphering the Enigma, if I'm not completely mistaken. But this is capital B. He was also one of the foundational characters in computer science, let's put it this way, because he came up with a very important notion in theoretical computer science called an automaton. Automaton? Automaton. In terms of you have a little gadget that does a couple of operations, and that's about it. In terms of you have a tape. The tape can be moved into 2 directions, and the tape can be read from and written to. And you have a little automaton that interprets the whole thing in terms of it can move the tape, and it also can interpret what is on the tape and can write with the tape. Essentially a computer, because this finite automaton is essentially the foundation for all computers on this planet. So Turing completeness means basically if you have an algorithm that can execute that sort of gadgetry, you can simulate any other Turing automaton.
Simulate any other Turing machine, right?
Exactly. And that's exactly what Turing completeness is. Yeah. Exactly. So almost all, and there may be a few programming languages out there that are not Turing complete, but the rest of them basically would be Turing complete in terms of they would implement exactly this sort of approach to algorithmic execution, so to speak.
Yeah.
And of course, Brainfuck, Ook, Bullshit, and all the rest of them would also be Turing complete.
Are they?
Although, yes.
Sure?
White space I'm not too sure about. Read it from the show notes.
Yeah.
But yes, they can all execute an algorithm. So they would be, by that very definition, be Turing complete. So the next time you buy your Brainfuck interpreter off some darknet site, just make sure that it actually...
Yeah.
Yes! But I mean, maybe you don't want to kind of download the source code and compile it yourself. You just want to buy an executable exactly off the darknet. Just make sure it has a label on it saying Turing complete, because in that case you get the real deal, if you know what I mean. Just
like
in case you're wondering.
Inside, is it?
Exactly.
Okay. Yeah. Other CPUs are available. Yeah.
So we missed one thing, right?
What do you mean we missed one thing?
OMG ROFL.
Well, there's a whole bunch of joke ones, right?
Yes. You already alluded to Arnold C. Why don't you take it away?
Oh, it's actually quite funny if you read it. It's based on the reason it's called Arnold C is because it's based on Arnold Schwarzenegger's sayings, like "It's showtime, you've been terminated," for end and stuff like that. You know.
Okay.
So yeah, if you've seen your Schwarzenegger movies, you can program in it.
There's a ton out of them, and there's also a website called Esolangs or something like that. Details, of course, within the show notes. That basically go through all of them. It's a funny read if you have the time. But I mean, if you can't get to sleep, that's the website you want to look at 2 a.m. in the morning or something. Just in case.
Yep. Yeah, stuff like OMG Ruffle. It's also quite funny.
We should probably explain what OMG Ruffle means.
Well, they're what do you call these things?
Acronyms.
No.
Martin, OMG Ruffle would be an acronym.
Well, yes, but there's another word for them.
Advanced technology? Is that the one I'm looking for?
Probably not.
Okay.
I mean, they are abbreviations, but yeah. They just came about with text messaging, didn't they? But did they not have a name of their own?
Yes, you mean SMS back in the olden days, yes. OMG, of course, means oh my God, and ROFL means rolling on the floor. Rolling on floor laughing.
Yes,
and that pretty much accurately describes that language. Yeah. We won't go to the details because we don't want to drive you into insanity right now listening to this podcast. Details, of course, within the show notes. Proceed at your own risk, I might add.
It's quite a it's quite a fun way to, if you're used to just writing stuff in whatever your usual programming language. Then it's quite fun to see how other people have done it just for fun.
Yes.
There's things like Chef as well, right? Which is
there is, yes. Is that one of the automation thingies?
No, there's also a Chef program.
Like Ansible or something?
Yeah, you're thinking of Chef and Puppet, right? But
yes, exactly. Yeah. but apparently it's a different technology.
This is Chef, the programming language, where you write with ingredients.
Excellent.
So your ingredients are your variables, and then your method is your function type stuff, right?
That almost sounds like this employment tool, no?
Indeed.
You have recipes to all the rest of it, no?
Yes. Well, the names were chosen for similar reasons, I'm sure.
I mean, the syntax may be different, but apart from that...
Yes. Yeah.
Okay. Is there anything we should mention before we close this off? I wonder.
Well, I think we should probably mention that
Rust.
If you like this kind of things, then look into them. There's a whole load of them, and they're quite fun.
Yes, of course. Martin got a restraining order, so he can't mention Rust for a reason. Am I?
Oh.
Because that wouldn't be one of the esoteric.
We also had the Rust Foundation on, didn't we? When was that?
Yes, we had Rebecca on the show, and we also had Steve Klapnik on the show, who was one of the major contributors. So, Martin, that proves that Rust isn't an esoteric language as such. Unless
no. Just because they have a foundation and one maintainer is not esoteric.
No, Martin. Just use your favorite search engine and type in the magic word Rust adoption code base and word domination.
Oh, I'm sure this is all
and
AI
see what
generated.
comes back. Jason O. Martin.
I wonder if Rust Adoption actually comes up with Rust the language or Rust the metally stuff. But anyway,
for example, there's a company called Oxide or something like that. That is,
sorry?
I think it's called Oxide. Links maybe in the show notes. Steve actually works there, if I'm not completely mistaken. It's Steve Klubnik. The idea is basically they give you a couple of racks, and then they give you a front end where you can configure these racks to your liking. Essentially, what they do is they give you a cloud on-prem to your very own liking.
I mean, a cloud on-prem.
I mean, that's exactly
that's not a cloud, is
it? They give you a rack, they give you orchestration, all the rest of it, and this is actually written in Rust.
But that's just a piece of hardware. It's not a cloud.
Plus a lot of software.
Cloud is someone else's hardware.
You see, you can rent that out, and then you can sell it, and then you can rent it back, and then you can rent it back. But the idea is basically, instead of giving loads of money to your hyperscalers of choice, buy the hardware yourself, but distribute the load, as in who does what on these racks. And that's exactly where this technology comes into play.
Run Proxmox, right?
It's way more than Proxmox.
Is it?
They give you containers, they give you VMs and all the rest of it. And do this in a very clever orchestration, with a very clever orchestration layer, which is precise because it controls your own hardware instead of.
Isn't that? Well, anyway, carry on. Keep going. Yeah.
Think about it like Kubernetes and speed, but Kubernetes is not stopping at the pod level. Sorry, it's getting a little bit technical now. Kubernetes is
and slightly unrelated to programming languages.
Exactly.
Yeah, carry on.
Think about basically Kubernetes on hardware. So not on hardware, but for hardware. In terms of way more than Kubernetes just addresses pod scale and all the rest of it. Think about it.
Yeah, that
like software-defined
really
hardware.
As a analogy, because you can't just magic up some hardware, right? You either have hardware or you don't.
Links will in the show notes. Oxide, if you're listening, the email address is
it's a scam. Don't fall for it.
If you look at the numbers, I'm not sure if they're public or not. The rest I can't disclose. But if you take, the
don't
adoption is brilliant. No, seriously. If one of the core Rust guys chooses to work there must be something behind it. And we had Carl on the show, and Bottle Rocket
runs on the bookshop. Yeah.
Yes, and if the bookshop decides to adopt that technology, there must be something behind this.
Well, we don't know what they adopt. Really.
Because the bookshop is not stupid.
They don't tell you anything.
Well, we could. Carl has moved on, has he now? Apparently.
I guess the bookshop wasn't for him anymore.
Fair enough.
He had too many books already.
And with that, it's probably worth moving back to the way safer grounds.
Oh, yes.
As the Poxies. What's a Pox?
Oh, the Poxies. Right. Yeah. Well, it was a difficult choice. There were the whole esoteric languages stuff was kind of interesting, so I got stuck with that one. But my vote goes for Arnold C. Really, it's brilliant.
Doesn't know. Okay.
Yep.
I'm tempted to say my heart goes actually out to Zeke, and not just because we had them on the show.
Yeah, we should.
But also, the approach is kind of interesting. And
I remember their founding model was really interesting as well. Yeah.
And I'm also almost tempted to say that Forth would be a very close contender, because this was one of the languages I grew up with.
Right.
All those years ago, when I had this little ZX81 in front of me, and the languages of choice were either assembler. That's actually when I fell in love with assembly language all those years ago. Basic, that came with the machine, and Forth, you had to install separately from a tape. You're talking about 40 plus years back.
Like 50, no? Anyway. But
no, you're talking about kind of early 80s. Like 45, something like that. Exactly, yes.
Okay. Yeah. Fair enough.
And with that,
what happened to
we
your
would
ZX81 anyway? Yeah.
I think I sold it about 2 weeks ago for about 5 million euros because some idiot was willing to pay that money for that sort of hardware. No, I'm joking. I think it got lost in the strand of time, yes.
It didn't break down. It was just... I remember that keyboard being really bad.
I mean, it wasn't the cloud compatible, so...
Yeah. Fair enough.
And with that, we would like to thank you for wasting another hour of your lifetime. Jokes aside, if you call to action. If you like that sort of thing, or if you don't, yes, send mail to feedback@linuxinlaws.eu.
Yes, we haven't had any feedback for a bit.
Yes, for about 2 days.
Okay.
Since people discovered that you can send all sorts of web hosting and website manufacturing scam mail to this mail address, but since we deploy very sophisticated artificial intelligence on that mail address, people don't bother sending mails because we won't read them anyway, because we will not get them. Simple as that. Because AI does a beautiful job of filtering them out.
Excellent.
And with that, see you next time. This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
We hope you liked this feature presentation. If so, please spread the word. If not, please let us know. Feedback at linuxinlaws.eu.